So now we're going to solve linear equations. And so basically what that means is that we're going to solve for a single variable without any exponents or anything else that we could maybe introduce. It's going to be pretty basic. We're just going to use addition, subtraction, multiplication, and division to solve these. So the first couple that we're going to do, you probably might be able to do in your head, and that's good. But as we move forward, they'll get more complicated, and so we want to make sure we understand how to apply these properties. So the first one is the addition property. So if we have two sides that are equal, so let's say A equals B, if you were to add some value C to both sides, it would still preserve the equality that exists. Okay. The additive inverse property is basically saying that if you add two opposite values together, it will equal 0. So as we solve these, just kind of keep in mind we're going to be undoing what is occurring to the variable, the unknown value. So let's go ahead and take a look at some of these. So like I said, this first one, you're asking yourself, what value, if you take away 8, would you be left with 9? And so a lot of us already know the answer to that. But we're going to go ahead and solve it by using our properties of equality. So I'm going to kind of color code this for a second. So x minus 8 equals 9. I put a little extra space there. And so what I'm going to do is I'm going to nullify the minus 8. I want to undo that. And so the opposite of subtracting 8 would be to add 8. So I'm going to add 8 to both sides. And so what happens here is those are going to cancel each other out. Those are opposites. So minus 8 and a plus 8 cancel out. And so we're left with x equals 17. So I said, many of y'all probably could have figured that out without having to do that. But that's kind of the process you want to do here. Another popular way that students will do this, and including myself, this is the way I like to solve these problems, is to solve them vertically. And what I mean by that, instead of having to rewrite it, what I would do is I'd just put a plus 8 here and a plus 8 here. And so that cancels out, and I'm left with x equals 17. So that's kind of the vertical approach, and I'm a big fan of that, but you do have to be careful. So if you look at example B, the opposite of subtracting 7 would be to add 7. So I'm going to go ahead and add 7 to both sides. So this cancels out, and I'm left with x equals. Now, this is where students make a mistake. They accidentally say negative 16 because they're like, oh, yeah, 9 plus 7 is 16. But right now, one of them is negative. You have a negative 9 plus 17, so you have that little tug of war going on here. So what you really want to do is take the difference of the two, which would be 2, and then keep the sign of the larger number, so it's a negative 2 right there. Okay, so just be careful as you work these. Okay, so looking at C, let's see. So this time, to nullify the plus 6, we're going to subtract 6 from both sides. And so that cancels out here, and we're going to be left with x equals 10. Take away 6 would be a 4. Okay, our next one, we're going to take away 8 from both sides. So we take away 8. That cancels out on the left side. So I'm left with x equals 5 take away 8. Or if you want to look at it as 5 plus a negative 8. And so you have that little tug of war going on. So you take the difference, which is 3, but then you need to keep the sign of the larger number. So it's going to be a negative 3. Okay, the last two we're going to look at on this page, they just kind of are set up a little different. So you see this time I have the 8 and then plus x equals negative 4. If you don't like that, you can switch the order and write it as x plus 8 equals negative 4 if you want. Addition is commutative, which means you can swap it if you want. Okay, I can't say the same for subtraction, though. You can't swap those. So looking here, what we'll do is we'll go ahead and subtract 8 from both sides. So I have x equals, so I have a negative 4 minus 8, which is basically negative 4 plus negative 8. Okay, so if I'm subtracting, I can write it as plus a negative. So I'm adding two values with the same sign. So just add them together and keep that sign. So x equals -12. Okay, on F, the variable is appearing on the right side. You can leave it there, or if you want to, you can rewrite it like this. If you want to rewrite it and swap the two sides, so x minus 17 and then equals -8. It doesn't make a difference. You could have just left it there. Either way, what you're going to do is add 17 to both sides. And so then once again, you kind of have a little tug of war. You have a -8 and you're adding 17. So I'm going to take the difference. And so let's see, that'll give us a 9. But then it's going to be, yeah, +9 in this particular case because the larger number was positive. So x equals 9. Okay, so I know probably a lot of y'all could do some of this in your head, and that's good. But like I said, as we move forward and they get more complicated, that won't be the case. Okay, the multiplication property of equality. So basically what that states is if you have A is equal to B, then you can multiply some value C to both sides as long as C is not 0, and it will preserve the equality. So C can be any value, just don't let it be 0, or else that will mess up your equality here. The multiplication inverse property. That basically just states that if you multiply a value by its reciprocal, it will result in a 1. So for example, 3 times 1/3, the reciprocal or the inverse, you just flip it, is 1/3. That would equal 1 right there. Even if you had like, -2/5, the reciprocal of that would be -5/2. And that still would result in a 1 right there. So whatever you have here, you just flip it, and that's the reciprocal, and the product is always going to equal 1. So once again, just kind of keep in mind that when you're solving this, you're kind of undoing what's occurring to the variable. So if we look at this first one right here, we have 7 times x equals 28. Now what you could do is you could multiply both sides by the reciprocal of 7, which should be 1/7. Or what might be a little bit easier, just go ahead and divide both sides by 7. So I'm going to undo the 7 times x by dividing by 7. Now what I do to one side, I have to do to the other side. So I divide both sides by 7. So the 7's cancel out on the left, and I'm left with x equals 4. That's what I get for my first one. Our next one, so I have 5 times x equals -70. So if I want to nullify that times 5, I'm going to divide by 5. So I'm going to divide both sides by 5. That cancels out here to isolate the x. So x equals, and I believe that will be -14. So I had a negative divided by a positive, so it gave me -14. On C here, we'll divide both sides by -4. So see, the -4 divided by -4, that's going to turn into just a 1, right? So it leaves me with 1 times x, which will just be x. And on the right side, 20 divided by -4. 20 divided by 4 is 5. One's positive, one's negative, so it's going to be a -5 is going to be my result. Okay, looking at D, we'll go ahead and divide both sides by -3. Now, in this particular case, I have a negative divided by a negative, so I'm going to end up with a positive. So 15 divided by 3 is 5. Okay, on E, we'll go ahead and divide both sides by 6. So that cancels out right there. So x equals, let's see, it's either, what is it, 0? So a lot of times students, they get a little confused. Is it 0 or is it undefined? And so we've talked about this in previous videos. And so just be careful. If 0 is under the line, then it would be undefined. So a little way to maybe kind of remember that. So if you have a number divided by 0, then that's undefined because it's under the line. that might help you out in the future. Okay, let's look at F. So right here, if you have a negative in front of a variable like that without a number, it's understood as a -1 right there. So you really have -1 times x equals 14. And there's actually two ways to solve this. Since we're kind of dealing with we've been dividing with most of these, we can go ahead and divide. So you can either divide or multiply both sides by -1. And all that does is cause a sign change. So that's going to turn this negative x that we originally had up here into a positive x. And then it turns that positive 14 to a -14. So either way, if you multiply both sides or divide both sides by -1, that's what will occur. Okay, so if we look at G, we have 1/5 times x is equal to -3. That's the same thing if you want to. You can just put the x over 5 if you really want to. It's the same thing. You could leave it as 1/5 if you want. But what we're going to do here is to nullify that divide by 5, we're going to multiply both sides by 5. So we're going to multiply both sides by 5. And so that will cancel this out here and leave me with x equals, then -3 times 5 will be a -15. Okay. And so you can see h is already written in that same format that I converted this to. I could have left it like that and just multiplied by 5 on both sides if I really wanted to. Would have gotten us the same exact result. So here what we'll do is we'll multiply both sides by 4. So that will cancel out the 4's there. So then I'm left with x equals 32. Okay, so down here on the last two, we're going to have to deal with, it's a little bit more complicated. It's not too bad. You just want to multiply both sides by the reciprocal of the coefficient of x. So the coefficient's the value in front of x. So we have 3 over 8. So I'm going to multiply both sides by the reciprocal, which would be 8 over 3. 8 over 3. And so see what happens here is the 8s would cancel and the 3s would cancel. Basically, by cancel, I mean they reduce down to 1s. And so what happens is you're just left with 1 times 1 over 1 times 1. And so this all just simplifies into 1x. But we don't put the 1 in front. We just write x. Now, on the right side, I've got 9 times 8 over 3. A lot of times if they're not both fractions, I'll turn the other one into a fraction. I'll just put it over 1. So it can kind of put everything on a level playing field. And so if you want to, you can multiply going across if you want, but I would go ahead and simplify as early as you can. So you can see right here, the 3 and the 9 can simplify. Okay. So then we're going to be left with 3 times 8, which is 24 over 1. And then you'll want to go ahead and just write that as 24. Let me go ahead and write it right here. X equals 24. So you don't want to include the over 1. It's extra information that's not necessary. Okay, so looking at J. So I do have a negative. It's out in front, so you can put it with either or. Don't put it with both. You got to pick one. I like to always put it on top. It's my personal preference. So that equals, let's see, 4 over 9. So we'll multiply both sides by the reciprocal right here. So we're going to multiply both sides by 6 over -5. 6 over -5. Okay. So on the right side, the 6's cancel, the -5's cancel. So I'm left with a 1x, or just x. Then on the right side, let's see, the 6 and the 9 can reduce. So we'll go ahead and do that down to a 3, that down to a 2. So that's going to leave me with 8 over -15. And you can leave it like that if you want. If you want to put the negative with the 8 instead, that's fine too. Either one of those are correct. Okay, so now that we've kind of played around with the properties of equality, we're going to start getting into multi-step problems, and that's what we're going to see on the next slide. Here we go. So solve the following equations. So I have the steps over here for this. So you want to simplify each side separately. So if you look at problem 3, what you can see is, and a lot of times I like to draw a line to differentiate the two sides. You could see that on the left side, you could kind of clean things up a little bit. You could distribute and have some like terms that we're going to combine there. Step 2 is isolate the variable term to one side. So if the variable is appearing on both sides, as you can see on number 5, you need to pick a side. It really doesn't matter which side, but you need to pick a side and somehow isolate it to one side. And then isolate the variable completely once that takes place. And then we'll check our answer. We won't check them all, but maybe we'll check a couple of them just so you can see how this works. So remember the idea that you're going to undo what's happening to x. So you kind of want to keep that thought here. So you have 7x's, you're going to take away 5, and it's going to equal 72. So the first thing I need to kind of do this in layers, right? First thing I'm going to do is undo this minus 5. So I'm going to add 5 to both sides. So I add 5. So this will cancel out here. That will leave me with 7x equals, what is that, 77. And then, so I have 7 times x. I don't want 7x's, I want 1x. So I'm going to go ahead and divide that by 7. So then I have to divide the other side by 7. And so when I do that, I'm going to end up getting x equals 11. And there's my answer right there. Now, like I said, I'm not going to check all of these, but we can go ahead and check this first one, see if it works out. So if I let x equal 11, I'll get 7 times 11 minus 5 equals 72. So I'm going to put a little question mark there. We're checking it to see if that's true. So I get 77 minus 5 is 72. Yep, there we go. The two sides are balanced. Okay, so let's go ahead and take a look at number 3. So this time I can kind of clean things up a little bit on the right side. So first thing I'm going to do, there's an understood 1 right here in front of that parentheses. I'm going to go ahead and distribute that right there. Okay, so I'm going to have 11x minus 6x, and then those double negatives right there, that will become a plus 5, and then equals 40. Okay. So then what I have going on here is I do have like terms right here. So I can go ahead and do 11x minus 6x. So you have 11 of them, and you're going to take away 6 of them. So that will leave me with 5x. And then I have that plus 5 right there equals 40. Okay. So then what we'll do next is we'll go ahead and subtract both sides by 5. And so we're going to be left with 5x equals 35. Divide by 5, divide by 5. So we're going to get x equals 7 for number 3. Okay, I probably don't have enough room to plug that in and check it, but if you want to get some extra practice, that'd be one way of doing it. You could go ahead and plug it back in and see if everything simplifies nicely. Okay. So on number 5 right here, I've got 2 times x, take away 7, is equivalent to 6 plus x. So x is our unknown variable, right? So I have 2 of them on the left side. I have 1 of them on the right side. So I either need to, I could subtract both sides by 2x. Okay, that would be fine. Or I could subtract both sides by x. I typically like to do the smaller of the two, okay? So if you're looking on a number line, 1 is smaller than 2, right? So I'm going to go ahead and subtract 1x from both sides. If you want to put a 1 in front, you can. It's not absolutely necessary. It's understood, though, that there is a 1 right there in front, okay? So when I do that, I had 2 of them. I'm going to take away 1 of them. That will leave me with a single x there. Then I have, let's see, minus 7 equals, and then I have a 6 right there. Okay, so then my next step to isolate the x would be to add 7 to both sides. So we'll go ahead and do that. And so I'm going to get x equals 13, and there we go. Okay. And so if you want to, once again, you could get a little extra practice, plug it in and see the two sides are balanced. All righty, let's take a look at number 7. So once again, I have 7x plus 4 equals x plus 16. So once again, I'll go ahead and take off an x from both sides. So I'm taking 1 away from both sides. So that nullifies the right side. The left side, I had 7, but now I'm down to 6. Then I have that plus 4 equals 16. Okay. And so this should start to look familiar. It looks like the very first problem we did. I'm going to go ahead and subtract 4 from both sides. That'll leave me with 6x equals 12. And then the last thing we'll do is we'll divide both sides by 6. And so we're going to get x equals 2. Okay, on number 9, we're going to do the distributive property again. So that's something we haven't really talked about too much. We did see it earlier, but now I have more than just 1 or -1. In this case, I have a 3. And so the way it works is you just multiply everything separated by addition or subtraction by that value. So 3 times x, that'll be 3x. 3 times this -2 will turn it to a -6. Then I have that plus 7 right there, and then it equals, and then I have it again. So this time I'm going to double both of these. So this will become a 2x plus 10. Okay. And then if you want to, I like to draw that line to kind of separate. So remember, I got two sides. Don't want to accidentally start adding the 2x and the 3x together. Those are on separate sides. So let's see, I have a -6 and a +7, so be careful when you add those together. You got that tug of war going on here. One's dragging you in the negative direction, one's dragging you in the positive direction. So take the difference, which is a 1, and then it'll be positive because the larger number was positive. So that'll turn into a +1 equals, let's see, we got 2x plus 10. Now it's time to figure out where we're going to isolate the x to. So we'll isolate it to the left side. What we'll do is we'll take off 2 x's from both sides. And so this will cancel on the right side. On the left side, this will simplify down to x plus 1 equals, and then we do have the 10 right there. And then our last step will be subtract 1 from both sides. So we end up with x equals 9. Okay. All right. So on number 11, it looks really messy, right? That looks pretty complicated. But if we just take it step by step, it's really not going to be too bad. Each step is not, is not impossible. And so if we just take it a little at a time. So the first thing we'll do here is multiply both of these by 3 with our distributive property. So 3x, and then this will become a -12. Okay, now this is something we haven't seen yet. I'm going to have to distribute a -4, so I'm going to have to multiply by -4. So negative times a positive, this will become -4x. Now I have a -4 times a -3. Basically, kind of think of it as negative. A negative and a negative will become positive. So this will become a plus 12 right there. Okay, so hopefully you're okay with what we did right there. Okay, on the right side, let's see, we have x plus 3, and then here you have a minus parentheses x minus 2. So we're going to distribute that -1. So that's going to just cause a sign change. So a negative times a positive is negative, so it becomes minus x. And then a negative times a -2, double negatives, so that will become plus 2 right there. Okay, so now it's time to clean things up. And so keep each side, separate. So looking on the left side, let's see, I've got 3x's here, and I've got a -4x here. So I'm going to combine those together. So I know it's all written out in a line, but you can kind of think of these as kind of floating around. And so I grab the 3x, I grab the -4x, and so those are different signs. So take the difference, keep the sign of the larger, So that's going to turn into a negative x right there. Okay, and then I'm going to grab the minus 12 and I'm going to grab the plus 12. Now this is kind of fortunate because they're opposites, and so they actually just cancel each other out here. So those cancel out. So my left side just turns into negative x. That's the only thing I have. And I'm going to go ahead and move it a little bit closer over here. So I'm just left with negative x equals, and then let's see what happens to the right side. Um, Same thing actually here. I've got a negative x and I've got a positive x and a negative x. And so those are opposites. So those actually just cancel out. So that actually worked out kind of nice. Then I have a plus 3 and a plus 2. Plus 3 plus 2 is a positive 5. When you add those together, same sign. So it turns into a positive 5. So I've ended up with negative x equals positive 5. And so I need to cause a sign change. So I can either multiply or I can divide both sides by negative 1. And that causes a sign change for everything. So my x becomes positive and then the 5 becomes negative. And there we are. All right. So just takes practice. Once you do enough of these, you'll find them fairly simple, but that the main thing is getting that practice in. Hopefully we're okay with the distributive property here. If you have any questions, feel free to reach out.